So moving on. Good. I want the book, and I want to talk about 65. So let's look at 65 and analyze what's happening here. Is x1, do you think, a critical number?
No.
X1 is a critical number because if the function has a minimum, which has a local minimum, obviously, if it doesn't have a critical number, it will never have a local minimum. So x1 is a critical number.
So it's a local minimum, but absolute minimum in this case would be x8.
But still, it's a local minimum as well. So the absolute minimum is indeed at x sub 8, but it's also a local minimum because it's in the middle of the function. I'm going to explain the absolute very soon. Good. Is x2? Is x2 a critical number?
No.
So this may be a critical number. I don't know the function. The way the function looks like, it doesn't appear to be a critical number. But it could be a critical number, but the function at that point does not have a max or a min. So the function can have critical numbers coming from f prime being undefined or f prime being 0. It doesn't appear here that the function is the derivative is undefined unless it's a corner. Now, if it's smooth, then I will say it's not a critical number. But if it has a corner somehow, then it is. So for now, let's say it appears to be a smooth curve and GS is correct. I would say this is not a critical number. But here, for example, this is a cusp or a corner. This is a critical number coming from the function, from the derivative being undefined. So this is a critical number coming from the function prime being 0. This is not a critical number unless we don't see clearly and it's a corner. Let's assume it's not a corner. If it's not a corner, it's not a critical number. I completely agree. This is a critical number. It's a local maximum. And this critical number comes from the derivative being 0. This one is also a critical number, but coming from the derivative being undefined. Because it's a corner. The function doesn't have a derivative here. But the point exists. So it's a local minimum. But G prime is undefined. That's why it's coming from the second source. What about this one? It's a local max. Does it come from the first source or the second source? Meaning the derivative equals 0 or the derivative equals undefined?
The first source?
Yes, the derivative being 0. Awesome. What about x sub 6? Is a
first?
Yes, it's a local minimum. It comes from f prime being 0. Excellent. What about x sub 7?
Would that one be the second?
Exactly. The point exists, but not the derivative. So that's why we have to look for two different sources, because the function may have a maximum or a minimum, local max, local min, but the derivative doesn't exist at that point. It does not exist at x sub 4. It does not exist at x sub 7. Okay, what about x sub 8? We already talked about it. It's a local minimum, so it comes from the derivative being 0. Now, careful. Let's look at x sub 9. It's a vertical tangent here. The derivative exists or it does not. At the vertical tangent, does the derivative?
One.
The derivative does not exist. The derivative does not exist. So at that point, the function has a critical number coming from undefined, g prime being f prime being undefined, but it doesn't change sign. So notice again, and the last one is from f prime being 0. So notice again here. If you remember, I gave you that silly example. It's not silly. So the function does not, the derivative does not change sign. If it does not change sign and is always negative, even if we find a critical number, if it does not change sign, this critical number cannot be a local max or a min. The derivative must change sign for this point to be something. So back to the graph. So here, this is a critical number coming from f prime being undefined, but the derivative is always positive because the function is always increasing. See here, this is undefined. The derivative is undefined. But on the left-hand side, the slope is positive. And on the right-hand side, the slope is negative. So this point is a local maximum. This one is a critical number coming from f prime being undefined because it's a vertical tangent there. But the function always increases. So that's why this is not a point of extrema, we say. It's not a max, it's not a min. Okay, I would like to continue now studying the second derivative. So this is 3.2, so the second derivative. Let's refresh our memory one more time. What does f prime say, not the second, but still f prime, what does it say about the function? It gives max min if it changes sign from positive, 0, or undefined, negative, and from negative, 0, or undefined, positive. If it doesn't change sign, the function, even if it has critical numbers, if the derivative does not change sign, so this is for positive, negative, so this is for max, and this is for min. This is one thing that we learn about the function from the first derivative. Here's the second one. Increasing or decreasing intervals. So coming back to the previous example for a moment, what did I find from f prime? I found that this function between negative infinity and negative 1 is always decreasing. Between negative 1 and infinity is always increasing. And I also found that this function has a local minimum because it changed sign. The derivative changed sign from negative to positive. And here I either have 0 or undefined. So this table tells it all. I don't have to write any of this. And I please don't. This is it. If you ask me from the table, I can tell you everything about the function. You say, show me the intervals of increasing. Okay, negative 1 to infinity. Show me the interval of decreasing. Okay, negative infinity to negative 1. Show me if it has a maximum. Sure, negative 1, 1.61 is a local minimum. Done. Good. Now, let's see what is the secret that the second derivative provides about the function. Also two things. Number one, concavity. Concavity. What is that? If the function holds water or it doesn't. Of course, that's not how we say it. Concave upward, concave downward. Upward, downward. concavity. Points, second item, points of inflection. Points of inflection, what is that? It's where it changes concavity. What does that mean? Exactly the point where from opening down at this point opens upward. This is the IP, the inflection point. Or from opening upward to all of a sudden opening downward. Notice that this is not a point of max min. This is a point where the function changes concavity from opening upward to opening downward, or vice versa, from opening downward to opening upward. A lot of information comes from f prime and f double prime. A lot. Good. So let's analyze this. And let's look at, see how we determine concavity and points of inflection now. And then we can put everything together and finally we can graph. But without these two pieces of information, we are not able to. Okay. Page 291. First, I'd like to look at a graph. Let's say problem 6. So follow the mouse, please. Decreasing, 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 decreasing local minimum. Increasing, opening upward. Uh-oh. Opening downward. Increasing to a local max. Opening downward. Uh-oh. Switch. Opening upward. Comes to a minimum and continues to increase. One more time. Decreasing to a local minimum. Increasing now. Oops, OP. At this point, changes concavity. Opening downward, downward, downward to a maximum. Local maximum continues to decrease. Uh-oh. Changes concavity again. Opening upward, coming to a local minimum, increasing to infinity. Can anyone identify for us the points of inflection, roughly?
Is it 1 and -1?
Yes, but I said points, correct. So this is problem 6 on page 291. So inflection points. Good. Roughly. Can anyone give us the not just the x value, the whole inflection point?
-1, 1, and
Oh.
1, 1.
Excellent.
I have a question.
Yes, please.
So with the inflection point, how do you know like at which exact point like it's switching from open?
That's what I said approximately, because from the
Okay.
graph, excellent question. From the graph is hard, but we are going to determine them now manually. Very good. Very good. So the next set of questions deal with just everything. Let's read the question. Give the coordinates of any critical points. Fine. Relative max, relative min, or none of the above. Identify intervals where the function is increasing or decreasing. So this is all about the first derivative. Do not confuse the first derivative to the second with the second derivative. The first derivative only says max min, increasing, decreasing, nothing else. There are some connections and there is some gray area, but I want you to identify and understand this. So first derivative, increasing, decreasing, done. The second derivative gives concavity and inflection points. Do not confuse the two. Give the coordinates of any points of inflection, identify intervals where concave up, concave down, and then sketch the graph. Okay? So allow me to choose the first one and then you choose the second one. let's say 13. 13 on page 291, and this is age of x equals x to the third minus 27x. So the question is asking us to find everything and then graph it. I get my table going right away. Look at the table, please. X is the variable in the problem. Then I have f prime. Of course, let me change this into f. I always write whatever and then change it to, by mistake, to f prime. So let's keep it as f prime. It doesn't matter. You can keep it as h of x. So notice the sequence. The first row, values of x. The second row, values of f prime. The third row, right in the middle, the values of the function f of x. The last row, the second derivative. Okay, now, can anyone give us the domain? Because I have to start here. Can anyone give us the domain of this function?
Is it that one just all real numbers?
Yes, because it's a polynomial. Thank you very much. Polynomials are defined everywhere, no headache. I don't even have to think. Perfect. Good. Now, I have to continue. Normally, what I need to do is find x and y intercepts, and limits at infinity. So why all of a sudden I'm bringing more information in? Because in the previous examples, we were only asked to find critical numbers. Now we are also asked to graph the function. When I graph a function, I also need the x and y intercepts. And furthermore, I need the limits left and right, because it's a polynomial function. Okay? So we always have to determine this for any function. Good. So let's do that first before we continue with the first and then the second derivative. So I have f of x, which is x to the third minus 27x. Can anyone give us f of 0? 0 has to be in the table. Can anyone give us f of 0?
Zero.
Of course, thank you very much. So we determine f of 0. So now I also have to find f of x equals 0, solutions to the equation x cubed minus 27x equals 0. If you don't want to factor or try to whatever, put it in the graphing calculator. I'm okay with that. And go to apps again, choose 9. Yes, but this time is a cubic. Okay, be very careful how you enter the coefficients. Look at this. The first coefficient is 1. The second one is 0. The third one is negative 27. And the last one is 0. So careful, careful, careful. And then click on graph. So I found 2 solutions. 3 already had the 0 already. So I have x equals 5.2 and x equals negative 5.2. And I put them in the table. Right here. Negative 5.2 and 5.2. Now the limits. Very simple. Very easy to find the limit as x approaches infinity from x cubed minus 27x. And limit as x approaches negative infinity from x cubed minus 27x. Let me refresh your memory. You can also do this with a calculator, but it's too simple. Which of these two terms is the most powerful one? It's a silly question, honestly. Which of these two is the most powerful one? Is it x cubed or is it 27x when it comes to infinity?
The cubed.